Hey guys, this is Miss Peters, and welcome to how we're going to be doing lectures from now on. So with PowerPoint, I obviously am recording myself talking. I'm also able to write, like there we go. It is definitely not beautiful. I'm going to get a mouse and hopefully that will make my writing a little bit better. I can also highlight things that are important. And so as you're watching this PowerPoint, I do want you to pay attention to, and please let me know what you think about this way of lecture. Obviously, when we're back in the classroom, I'm not going to lecture through this, but while we're online, I want to help you do the best that you can in chemistry, and this is right now the only tool I can think of. So any feedback, positive, negative, please let me know with this. And so your notes today, most of this is in your notes packet if you want to go grab that. And so some things are new, some things are old. What I would do is obviously anytime there's anything new, write that down. If there's something that's already written down in your notes and I'm saying it again, obviously it's important. You might want to highlight that, underline it, star it, whatever you want to do. And so let's get started. So chemical bonds are formed when electrons are shared or transferred between two or more atoms. A chemical bond doesn't happen with just one atom. And then the only electrons that are involved are the valence electrons. Not every electron the atom has. So down here we have water, H2O. Oxygen has an atomic number of 8, and so that means it has 8 protons and 8 electrons. But the only ones that are involved with bonding are the valence. And so these two right here, the inside ones, they don't have anything to do with the bonding. Oxygen only has 6 that are involved with bonding. 1, 2, 3, 4, 5, and 6. And then hydrogen, hydrogen's number 1. He's only got 1 valence electron. Here it is right here in green. They are sharing their valence electrons. So there's a bond, and there's a bond. If you forgot your periodic table, the A number tells you how many valence electrons an atom has. So boron has 3, carbon 4, phosphorus 5, bromine 7, etc. The octet rule. Atoms bond to form an octet, which is 8 electrons in their valence level. Not 8 overall, not 8, I don't know where, in their valence level. And just about every atom wants to have an octet. Maybe you remember there are exceptions, like hydrogen only wants 2, but most atoms want the 8. Octet, you can remember when you see octet, octagon has how many sides? 8. And so today we are going to go over the properties of metallic, ionic, and covalent bonds. We did go over this before, as I said. So a metallic bond is when you have just a metal. Like this is just potassium. It has metallic bonding. When it's potassium chloride, it doesn't have metallic bonding anymore. It has ionic bonding. And then covalent bonding, it would be something like chlorine. Now, chlorine, do you remember Hofbrinkel? Chlorine's a Hofbrinkel, so it is Cl2. There are 2 chlorine atoms, so that's why it has covalent bonding. If you have, let's say, just P, just one phosphorus atom, that would not be covalent bonding because there's not 2 or more atoms. To have any bond, you have to have 2 or more atoms. But your diatomics, your Hofbrinkels, they all have bonding. Okay, so an ionic compound, metal and a nonmetal. The metal is our cation and it gives the nonmetal its valence electrons. We'll write their name, we don't use prefixes. And so cation, remember my little paw? Cations are positive because they lose that electron, and that is your metals. Oh my gosh. And then our anions, they take the electron. That's the nonmetal. And it looks for sure like a child is writing that. I'm sorry. Hopefully I'll get better with time. And so some examples really fast, just refreshing your memory. Sodium fluoride. Go to your periodic table. What's sodium's charge? it is a 1 plus. Fluorine is a 1 minus. That's its charge, not valence electrons. And so the formula is NaF. 1 sodium cancels out 1 fluorine. Calcium nitride. Calcium is a 2 plus. Nitrogen is a 3 minus. Those don't add up to 0, and so you have to cancel their charges. To cancel them, you actually need 3 calciums and 2 nitrogens. 2 times 3 is 6. 3 times 2 is 6. It's all canceled out. And then AuCl. If I were to write that name, Au, you're like, that's not one I know off the top of my head. Go to your periodic table. It's gold. Gold's a transition metal. Something in your brain should be like ding, ding, ding. Transition metals need a Roman numeral. The Roman numeral is the charge. And so, okay, it takes forever. Instead of figure out the charge of gold, well, let's look at chlorine. Chlorine has a charge of -1. There's only 1 chlorine. All ionic compounds are neutral. The positive cancels out the negative. So this gold must be 1 plus. And so when I write that name, it is gold 1 chloride. The 1 is for the charge of gold, not that there is 1 gold atom. There's a difference. Okay, covalent compounds. 2 nonmetals bonded together, and they share their valence electrons until each one has, or they're sharing 8. And when you write the name of a covalent compound, you use prefixes. So our examples, nitrogen trifluoride. Nitrogen, no prefix, so there's just one of them. Tri, like a triangle, there's 3 fluorines. So that formula is NF3. Dicarbon difluoride. Di, that is the prefix for 2. So that becomes C2F2. And then if you were to do the reverse, write the name, Br3I. 3 is tri, and so it's going to be tri, and then is it tribromine or tribromide? Well, let's look back at the examples. Dicarbon, nitrogen. I didn't write nitride, and I didn't write carbide, because you don't change the ending of your first nonmetal ever. The ending stays the same. So it is tribromine monoiodide. And then this I gets a mono because your second nonmetal always has a prefix. If it's 1, if it's 10, it always does. Just like CO is carbon monoxide, when there's just one of the second one, it gets the prefix. Okay, and so if I were to draw a Lewis structure for an ionic compound, so first thing you would need to do is look at this formula, barium sulfide. There are no prefixes, and barium's a metal, sulfur is a nonmetal, and so it's ionic. That is always your first thing you need to do. And then let's figure out what the formula would be. Barium has a charge of 2 plus, sulfur has a charge of 2 minus. So that formula is BAS. And so that means there's 1 barium atom or ion for every 1 sulfur ion. And so if I were to draw them, what they look like at the beginning before they bond, barium's got 2 valence electrons. Sulfur, how many valence electrons does it have? It doesn't have 2. That's the charge. It's going to take 2. Go to your periodic table. What group is sulfur in? It is in group 6. And so it has 1, 2, these are going to be my dots for now, 3, 4, 5, and 6. And so I suggest when you draw these Lewis structures, draw them how they are first. And then they're an ionic compound because barium gives its valence electrons to sulfur. And so these guys actually get erased. And doop. And it ends up with sulfur having 8, and barium having none. And because they have a charge, they're ionic, we're going to put them in brackets. And then outside of the brackets, we're going to write the charge for them. And so barium would have a 2 plus, sulfur gained 2, got 2 negative friends, so it's a 2 negative. And that would be the Lewis structure. Now on your paper, you would draw it a lot nicer than I am. If we were to draw this for calcium nitride, that formula, calcium is a 2, nitrogen is a 3, so it would be Ca3N2. And that would leave us with 3 calcium atoms and 2 nitrogen atoms. And so if we were to repeat what we just did before, which one gives away electrons, your metal or your nonmetal? Your metal gives them away. And so our metals always end up having none. So I'm going to draw them in brackets, charge, brackets, charge, brackets, and charge. And then each nitrogen, they have, how many does every atom want? Every atom wants 8. 1, 2, 3, 4, 5, 6, 7, 8. And I know they have 8 because this is a neutral compound. They're not exceptions. They have 8 when they form this compound. Or if you're like, I don't believe you, Miss Peters, each nitrogen starts off with how many valence electrons? 5 and 5, because they're in group 5. These calciums each have 2. And so these 2 went to him. Let's say these 2 valence electrons went to him. And then that leaves them with 7. 5 plus 2 is 7. And then this one, the valence electrons get split in between here and here, and then everyone's got 8. But you would not draw that for that Lewis structure. Okay. So metallic bonding. This is again when you just have a metal. And it's important to remember that you don't ever just have one metal ion. Even like the smallest piece of gold or the smallest piece of sodium, there are still tons of atoms, and all of these atoms stick together. And why they stick together? So in metallic bonding, the valence electrons are delocalized. That is an important word to know. The valence electrons, they leave. They're not in the spot where they're supposed to be. You can see them over here. That's them. They move around. They're delocalized, and they move freely, which means they just move around the piece of metal. And as they move around, they form what's called a sea of electrons, because they're moving, and if the ocean moves, these electrons are moving around the atoms. And what that does is these electrons are negative. These sodium atoms just lost their electron because it was delocalized, it left, and so now they're positive. Well, negative and positive, that is attractive to one another. All of these negative atoms are attracted to the atoms. And so that keeps them together because you've got negative and positive. Just like an ionic compound, negative and positive, they stick together. Well, in a metal, the electrons stick together to the atoms, even though these electrons are moving around, like he's here, he'll go here, he'll go here, here, here. They move, but they stick together because of that attractive force between the positive and the negative. And so that attractive force is called metallic bonding. It's just these electrons that are delocalized, they move, they're attracted to the positive atoms, and so they all stick together. And so some properties of metallic compounds. They're good electrical and thermal or heat conductors. They're malleable, which means you can change their shape easily. They're ductile. They can be drawn or pulled. I like to think of a wire. You can stretch them out. They're shiny. Yeah, and I think that's it for metals. Versus ionic and covalent compounds. And I do think some of this is kind of new stuff for my class that you might want to get down. Our ionic compounds. That's like salt, covalent compound, sugar. Do you remember burning those a while ago? Whenever you burnt them and you look like little crackheads? Well, did the salt burn? No, it did not. Because salt ionic compounds, they have high melting and high boiling points. They're hard and they're brittle. Most are solid at room temperature. And when they are dissolved in water, they conduct electricity, but not when they're solid. They do have to be dissolved in water to conduct electricity. And we're going to talk about why with that in our next unit. Covalent compound, the sugar. The sugar melted because covalent compounds have a low melting and boiling point. Oh, I also forgot to throw out ionic compounds conduct heat. Don't miss that. So yes, our covalent compounds, low melting and boiling point. They can be solid, liquid, or gas at room temperature. They aren't like ionic compounds where most are solid. And they don't conduct electricity if they're solid, if they're dissolved in water. If they're gas, they still don't. They don't conduct electricity. Okay, well that looks terrible. Can't even read. And then they don't conduct heat well. And so what is it called if something is not a conductor? They are insulators. So you are now going to go to Canvas and take the quiz over these notes. Please use the notes on them. I do want you to take the quiz until you get a 100. And then in the quiz, please give me feedback. Did I talk too fast? I know my writing looks childlike. Like, that is terrible. I'm going to work on it, and hopefully by next week, my writing on lectures will be much better. Okay, bye.